This week, we'll review the concept of choice, particularly as it relates to a certain quote-unquote law considered as part of the BACB task list objectives. Here's an example that was covered way back in ABA 500. Janie makes 70% of her three-point shots and 25% of her jumpers. After looking at her game day data, her coach noticed that about 70% of her shots came from behind the three-point line. Her omissions of behavior are proportional to the reinforcement produced by each, which can be explained by what? Matching law. That is the focus of this week's material. But let's back up. First of all, what is choice? How would we define it behaviorally? According to Fisher and Mazur in 1997, choice is an individual's allocation of time and responding across available options. That's a mouthful, but by assessing what choices someone makes, we can in turn infer what their preferences are. Preference for something is said to be observed when more responding is allocated to one alternative compared to others. Given that we have a multitude of options for behaviors to engage in at any given time, and each of those behaviors would be maintained by different schedules of reinforcement, what compound schedule of reinforcement do you think would be best to study choice? And what is the definition of a concurrent schedule? So, how does this relate to our applied work? The relevance to preference assessment should probably be clear, but you can also tie this into skill acquisition and behavior reduction plans. Consider this. How frequent does a schedule of reinforcement need to be for a new appropriate behavior to replace an inappropriate behavior? That is, when teaching a new skill or implementing DRA, what schedule should be used? An FR1 schedule is the rule of thumb, but why? Choice can be predicted and controlled, and by manipulating the schedules of reinforcement, we can make it much more likely that someone will choose to engage in the appropriate alternative behavior instead of the behavior targeted for decrease. Without knowing what precise reinforcement schedules are operating on behaviors targeted for decrease, FR1 is the only schedule that can effectively compete to be the first choice. Herrnstein was the first to intensively study what he called the matching law. In his initial experiments, two variable interval schedules were presented concurrently. What's the definition of a variable interval schedule of reinforcement? So, a high rate of responding does not need to occur in order for reinforcement to be earned. By pecking a key associated with one schedule, the pigeon's first response after an average of 135 seconds was reinforced. On the other, the first response after an average of 240 seconds was reinforced. With this being the case, it makes sense for the pigeon to alternate back and forth between the two options. That is what would have led to the greatest amount of reinforcement in the pigeon's learning history. However, reinforcement is earned more often during allocation of responding to the VI 135-second schedule. So what happened? Herrnstein graphed the data as a percentage of reinforcers earned from one key on the x-axis and percentage of responses made to that key on the y-axis. He found matching. The matching law states that the rate of behavior allocated to each option or schedule of reinforcement matches the rate of reinforcement that is earned with that option. Avoid mentalism and teleology and take a shot at explaining what is meant by the statement that behavior matches reinforcement. Remember, mentalism is ascribing cause to something that cannot be observed or measured, and teleology is explaining something based on an event that has not yet happened. So to get you started, behavior matches reinforcement because, in the past, here are some results of 3 pigeons that participated in Herrnstein's original study. Again, the percentage of responses made to one of the keys is shown on the y-axis, and the percentage of reinforcement earned on that key is shown on the x-axis. As the amount of reinforcement available increased, moving right on the x-axis, the amount of responding allocated to the key increased, moving up on the y-axis. Perfect matching is represented by the solid diagonal line going from the bottom left to the top right of the graph. All 3 pigeons' behavior almost perfectly matched the proportion of reinforcement available. With concurrent schedules of reinforcement, relative response rate will match or be about equal to the relative rate of reinforcement. That is what leads to a maximized amount of reinforcement. But that means that we really only see distribution of responding across multiple different options when we use interval schedules. If ratio schedules are used, rate of reinforcement is directly proportional to rate of response, so the organism will earn the most reinforcement by simply allocating responding to the densest ratio schedule. Meanwhile, on interval schedules, we see more clearly what the matching law predicts. Rate of responding allocated to each schedule will match the amount of reinforcement available through that schedule. Try rephrasing in your own words. When we study the matching law, why do we use interval schedules instead of ratio schedules? Here's another example from ABA 500. A red and a green key are both available. PECs on red produce reinforcement on an FI 2-minute schedule. PECs on green produce reinforcement on a VR2 schedule. What compound schedule is this? And what patterns of responding would you expect to be produced? Note that this is not a simple comparison between two VI schedules, so take a moment to really think through what kind of responding is produced by these type of schedules. Rate of responding would be higher and more consistent on the green key in accordance with matching law. Responding on the red key will be low to almost non-existent during the initial parts of the interval and increase only at the end until the reinforcer is delivered, and then responding will resume on the green key. In addition to different rates of reinforcement, concurrent VI schedules can also be used to study choices involving differences in reinforcer amount or magnitude. For example, you could assess whether pigeons allocate more responding to the options of 6 seconds of grain versus 2 seconds of grain, 4 pellets versus 6 pellets, etc. Of course, if the schedule of reinforcement is the same, responding will be exclusively allocated to the schedule that has produced more or longer access to reinforcement in the past. But what about quality of reinforcement? Miller in 1976 compared 3 different types of food, grain, hemp, and buckwheat, with equal concurrent VI schedules. Turns out pigeons almost exclusively prefer buckwheat. You can use the same type of concurrent schedule arrangement to conduct reinforcer assessments with your clients. There are a few procedures that you'll see in almost every instance of matching law research. First, experimental control is very important. The organism needs to be able to access the different operanda associated with each schedule with an equal amount of movement and response effort, and the operanda must be operated with an equal amount of response effort. If one key is easier to peck than the other, that might come to control responding more than the schedule of reinforcement. Given that matching law has been demonstrated again and again in our body of research, if any side bias is observed, we know that something else must be affecting organisms responding other than the schedule of reinforcement that we're manipulating. What are those variables called? Ones other than our independent variable that may affect the dependent variable. We can see bias in the results of matching law experiments when response proportions are consistently higher or lower than reinforcement proportions. Again, this means that something else other than the schedule is impacting response allocation. These days, in almost all matching law research, a changeover delay is included. This is abbreviated COD. It means that there is a penalty for switching back and forth between operanda. Usually, there's a timeout of a couple of seconds in which no reinforcement can be earned. This means that the first response, switching from one option to another, is never reinforced. This way, behavior is again under the control of the schedule of reinforcement exclusively. Otherwise, there would be no reason for the organism not to just switch back and forth continually. Switching in and of itself would be reinforced. Other types of deviations from matching, other than bias, are undermatching and overmatching. Undermatching occurs when response proportions are less extreme than reinforcement proportions. In other words, the organism is not responding enough to attain the corresponding proportion of reinforcement from that option. This is the most frequent deviation. It may occur when the COD is too short, which again would lead to more switching back and forth even when it doesn't ultimately lead to more reinforcement. overmatching occurs when response proportions are more extreme than reinforcement proportions. In other words, the organism is engaging in more frequent responding than is required to attain the corresponding proportion of reinforcement from that option. This is more rare, but may occur when the COD penalty is too long. This would lead to switching being actively punished, discouraging the switch even though it would lead to more reinforcement overall. When it comes down to it, the science of behavior analysis is all about predicting and controlling behavior. The choices we make in day-to-day life seem incredibly complex, but in experimental research we can isolate individual variables to assess their effects on behavior. A history of different proportions of reinforcement, contingent on each type of choice, is only one variable, but it's one that's been shown to have a huge amount of influence. In review, how can you apply what you know about the matching law in your work with clients? It's most commonly considered in conjunction with preference and reinforcer assessments, as well as reinforcing alternative behaviors in ways that will make them more likely to occur sooner in a response class hierarchy than behaviors targeted for decrease. But you can analyze even the most complex behaviors through a lens of what has best matched reinforcement in the past.